Hi, hello, this is Yoga Priya, Assistant Professor, Department of Computer Science. So, today we are discuss about ROM using diodes and transistors. The first one, understanding the ROM basics, what is ROMs and its applications. So, ROM is an read-only memory. It's one of the type of non-volatile memory used in a digital circuits and computers to store the data permanently. The information stored in a ROM is written once and cannot be erased or modified even when the power is turned off. The data ROM remains interactive. ROM contains the essential programs and instructions that computers or electrical devices to start up the functions properly. Yes, the topic is ROM using diodes and transistors. We have to choose the first diodes matrix, how it works. Yeah, a read-only memory can be built using diodes or transistors to store fixed binary data permanently. So these hardworks based ROMs are simple and widely used early digital systems, programs or looks tables. So first of all, ROM using diodes. So in diodes, information is stored in front of the connections, presence or absence at diode between word lines inputs or byte lines outputs. In this workings, each row's word line represent an address, each column's bit line represent a data bit 1 or 0. A diode is placed at the instructions if the data bit is 1, no diode placed if the bit is 0. So the next transistor, ROM using in transistors in these circuits. So the transistor based on a ROM used the transistor switches, usually MOSFETs, instead of diodes to control the data bits. Working principles is each memory cells consist of a transistors and a resistors. When a word line is selected, the transistor is the row determine the whether the bit line in connected to ground or remains is high. The transistor presents logic 1, no transistors, logic 0. The stored device's data is fixed by the transistor connections during the fabrications, and its applications and advantages faster and more efficient than the ROM diodes can be integrated easily with the other transistors based logic circuits. And then assessments, this it is used to do for students. So first one, track the address word line, and the second one, check the diode connections and decode the outputs. The first one, select an addressed input, example 2-bit address in a 4 into 4 columns. Second one, look diodes and connections, look the instructions, the achieves word line, the bit lines. The last one, decode the output bit lines. For each bit line, note the logic based he presents the absence of a diodes, and then combine the bits to from the binary outputs to the selected addresses. Yes, I share these some common challenge and solutions for students, and then quizzes max components for the functions, and then real world examples, diodes matrix ROMs driving the 7 segment displays. A diode matrix ROMs can be used to control a 7 segment display, which is commonly used in a digital clocks, calculators and counters. Each memory address in the ROM correspondent to a digital input, and the ROM outputs the correct combinations of signals to light up the segments of the display. And then finally conclusions. A diode matrix ROM provide a simple and reliable to the stored predefined the data patterns and drive the devices like 7 segment displays by encoding binary inputs address and fixed diode connections. The ROM outputs the correct signals to eliminate the appropriate segments from each digit. This approach demonstrates the practical applications of the ROM real world system, highlights its advantages of simplicity, reliability, and cost efficiency. While the modern system may use the microcontrollers of a programmable memory for a flexibility, diode matrix ROMs remains an excellent educational examples of how digital circuits can store and output fixed data patterns for display and the control purposes. Thank you.